So this is not a problem at all. But the deletion is done inside the SPL object storage. So unserialized doesn't know about it. And unserialized, you remember there was this variable table that's used for references. And so unserialized has still a pointer to this variable that was just freed. So when you now continues to unserialize and use a reference to the extra data that was already freed, it's perfectly possible because unserialized doesn't know that this variable doesn't exist anymore. So you can put in references to already deleted objects or classes or whatever, arrays or strings or anything. And now I will show you how you can use this for info leaks and code execution. First of all, I remember you of TikiWiki. You can have code execution if the application unserializes. But if you want like a really good exploit, you need that the application unserializes it, modifies it, serializes it again, and gives it back to you. This works in this case in TikiWiki. This would also work in pvik, or the old version of pvik that is not exploitable with property-oriented programming, but through this bug. And it should also be possible with OpenX, the most prominent ad software. So we will do leak after free attacks. The basic idea of leak after free attacks is that you give the application some serialized data. It will unserialize it, and the unserialization will trigger the exploit, the bug somehow. And what you want to do is you want to create some variables in unserialize and then free them. So there are a lot of pointers in the var table that point to non-existing variables, and all these variables are put to the memory cache, the free memory cache. The next thing you want to do in the unserialize is to create a string variable of the same length as the internal data structure used by PHP to keep track of variables, which is called setValue. And if you create a string inside the unserialized that looks like a fake setval, it's theoretically possible to use it. And because of the memory cache, it will be allocated in the same spot as the previously freed variable. And what you can do now is you can use the references in the unserialized to create a reference to the already freed variable. And because instead of the variable there's now your string, you have full control about the variable that is created inside of PHP. Because you actually have you can change the binary representation of the variable in memory. Yeah, so all leak after free attacks will work like this, and in the end we just read the serialized result back, and yeah. So what we want to do first is we want to leak arbitrary places in memory, and we can do that with the kind of attack. What we do is we create a fake string variable inside PHP. A string variable inside PHP consists of the string pointer, followed by the string length, followed by a reference counter, followed by the byte 6, which says this is a string, and then followed by a byte of 0, which says this is not a copy on write variable. So what we have here is we have told PHP that just obviously a string variable in memory starting at B7342118, which is a pointer, a 32-bit pointer, and PHP will believe that if it sees this variable and the reference to this variable. And when it modifies now the unserialized data and gives you the serialized form back, it will go to this string and see, oh yeah, I have to take the 1024 bytes from this piece of memory and give it back to him. So to actually achieve the attack, you just have to send this little piece of serialized data. What it does is, first it creates an array of integers. Then it frees the integers. It frees the arrays, and this frees all the integers. This means you have a lot of free variables right now and a lot of references in the var table that are pointing to not allocated memory. And now you put up your fake set val, and because of the memory cache, it will be allocated in the same spot of one of the previously integer variables. And when you then create a reference to the right variable, to the right slot of the freed variables, then you suddenly have full PHP that there's a string in memory at the data you supplied. And when you send this to TikiWiki, TikiWiki will give you something serialized back, and this will look like this. You see that there's a lot of garbage, but actually this is the memory content, and this, I think that was the code segment. It was, yeah, it was a code segment of PHP in this case. And of course, this is just garbage. You usually get the real thing, so you have the real bytes. And you just have leaked 1024 bytes of the memory. The problem here is, of course, when you put in this pointer I just showed you, most probably your system will crash because your PHP will not be at the same place. So you need a way to start where to look for. And this can be done with a more complicated way. Again, you create a fake string. But this time you put in any pointer you want, you don't care. In this case it's 41414141. And you will do more or less the same attack. It's just a little bit more complicated. The idea now is you have first to create an array of integers just to allocate something, to make the memory cache empty. Then you again create an array of integers that you free immediately again. So you have all these empty spots in the variable table. And then you create an array that contains the, your fake string and the empty object in alternating sequence. And then you freeze it again. And this is very important. You freeze it again. And then you create the reference to already freed thing. The idea here is the moment you free the fake integer, the fake string, the first 4 bytes will be overwritten by the memory cache with a pointer to the previously freed memory. So you have just created a string variable into a heap because you have just let the memory cache fill out the pointer that you wanted for you. Yeah, aside from that, the attack is the same. When you send this to TikiWiki, you get something back. And this time, you will take this memory and scan for it. You will scan for objects in there, because you had all the objects in memory. What you will search for is like 4 times 0, followed by 5, followed by 0, because this is the pattern that will help you to find empty already freed objects, because the reference count is 0, so, and it's an object. So when you find this in memory, you assume that the 4 bytes before are pointed to the object handlers. And the object handlers is a table, usually in the data segment, especially for PHP. Internal object is always in the PHP data segment. And yeah, so by just going through the memory just leaked, you can find out where the data segment of PHP is, at least the one struct that you are interested in now. And with the previously attack that allows you to leak anything, you can just grab the memory at this place, read in the handler table, and in the handler table you have a lot of pointers in the code segment of PHP. So what you have now is you know where some places of PHP are in memory, the code segment and the data segment. The code segment is more interesting. Because once you have the code segment, a pointer inside the code segment of PHP, you can just go backward page by page until you hit the executable header. In case of Linux, it will be an ELF header. In Windows, it will be a portable executable header. But for now, we concentrate on Linux, so it will be an ELF header. And you can just read the header because you can leak anything. So you can leak all the structures inside the ELF header, and you can actually steal the whole binary remotely. You can just grab every piece of the binary and get it through TikiWiki on your server. And of course, when you have a binary, you can look up all the symbols in memory. You know which function of PHP is. And you can also go through other modules. For example, PHP is linked to the Apache modules, so you can find the Apache core. And with the Apache core, you can find the other loaded Apache modules, for example, mod SSL, and from there you can steal the private SSL key from memory. But you can also use this information to create a code execution exploit. I will show you that now. So the idea is, to do the code execution exploit is you first need to know the location of the stack, because stack is usually completely randomized, even more than all the other things, so it's really hard to find the stack. But you can already look up any symbol in PHP, so what you do is you look up the executor globals. And the executor globals is like I think it's the biggest, no, second biggest struct inside of PHP. And one of these entries is the jump buff. The jump buff is the data used by setJump and longjump, and PHP uses this for emulation of try-catch at the C level. And what you can do is you can find the jump off pointer, and this jump off pointer is stored on a stack. So if you find the jump off pointer, you have an address in the stack. And of course, from there you can leak up and down as much as you want. Okay, until you hit like a page that is not allocated. The second thing is you want to have control of the stack, because you want to put some data structure on the stack that you can use for your attack. And PHP is actually very simple to get control of some piece of the stack, because you can send in a special type of post request, which is the RFC 1867 multipart form data, which is used for file uploads. And when you do an upload like this, the parser will use some stack buffers, and the stack buffers are very big, and they're in a way on the stack that the functions coming afterwards will not completely overwrite them, because the function afterwards will also have big stack buffers, so there is always a big slot that is never overwritten. So if you can find that and put arbitrary data there, you have injected arbitrary data to a known location in the stack. So what you do is you put in like a post request with a special layout and put in your pattern, and then you search just the pattern in your where they're leaking, and then you know the address of this stack buffer. And because in the PHP module it's all forked from Apache in the non-thread way, the stack will always be in the same place. So what you do now, what you do have now is you have a known location on the stack that contains your data. And what you want to do now is you want to create a fake object. You saw how we created fake string. Fake objects are more or less the same. And once you have created the fake object, you want to destroy it. The reason for that is when a variable is destroyed, it will call this setval detour func in the end. And in case of objects, it will go to the object handle table and use the second handler, the delref handler, and will delete it. When you look at the assembly, you will see that when this is called, the ESI register is